Okay, this is Jacob's Algebra, Chapter 11, Lesson 4, Part 2. When we stopped in Part 1, we were working on number 6. We had two different expressions, and we were going to evaluate those expressions for different values of x. So we evaluated that expression for x equals 4, and we got 16 for both expressions. Now we're going to do it for x equals 0. So if x equals 0 in our first expression, we have 0 plus 2 plus 6 plus 0 over 0 minus 3. So that means we have 2 plus 6 over negative 3. 6 over negative 3 is a negative 2, and 2 plus a negative 2 is 0. If we look at our second expression, we will have 0 squared over 0 minus 3, which is 0 over negative 3, and that is 0. This is not undefined. It's only undefined when 0 is in the denominator. And we don't have 0 in the denominator. We have negative 3. So again, these two fractions are, these two expressions yield equal numbers. The reason why is this. If we take x plus 2 and we add 6 plus x over x minus 3, well, in order to add these, we have to get a common denominator. So the x plus 2 is really a fraction over 1, and we're going to multiply it by x minus 3 over x minus 3. And when we do that, x minus 3 times x plus 2, I'm going to draw a little grid up here so that we can work this out. Okay, when we work this out, we have x minus 3 times x plus 2. X times x is x squared. 2 times x is 2x, negative 3 times x is negative 3x, and negative 3 times 2 is 6. So what we end up with is a common denominator of x minus 3. X minus 3 times x plus 2 is x squared. 2x minus 3x is minus x, and then we have a plus 6. I'm sorry, this is supposed to be a minus x. And now we need to add our second numerator, which is plus 6 plus x. I'm sorry, this is a minus 6. So this is actually a minus 6 here. So we have negative 6 plus 6 is 0. We have a negative x plus x, that's 0. So what we end up with is x squared over x minus 3. And you'll notice that is our second expression. So x plus 2 plus the fraction 6 plus x over x minus 3 is equal to x squared over x minus 3. Okay. So that was number 6. It's just like number 12 that I assigned for homework. So you should stop the video at this point and work number 12. Then come back to the video for the next problem. Okay, so number 7. The instructions say what should replace the shaded area in each of the following equations to make it true for all allowable values of x. Express your answer in simplest form. This means you are not done until your answer is in simplest form. So we're going to start with part B. Part B is 2x minus 5 over 10 is equal to x over 5 minus something. We have to figure out what that something is. Well, if we look at our original fraction, we have two terms in the numerator and we're subtracting them. And over on the right side of the equal sign, we have a fraction and then we're subtracting another one. So let's just break it up there. We can break this fraction up into 2x over 10 minus 5 over 10. Well, 2x over 10 simplifies into x over 5, which is exactly what we have here. Then we have the minus, and then we have 5/10. Now 5/10 can be simplified. If we divide the numerator by 5, we get 1. If we divide the denominator by 5, we get 2. So 1/2 is our answer. 2x minus 5, quantity, divided by 10, is equal to x over 5 minus 1/2. So let's jump down and look at part D. Part D is 9x over x plus 1 is equal to x over x plus 1 plus something. We've got to figure out what that something is. Well, we only have one term in our numerator, and it's a 9x. So if we tried to break that up, we could say that 9x is equal to x plus something. What would we have to add to it? We would need to add 8x. So we can break that into two fractions, x over x plus 1 and 8x over x plus 1. So that is actually going to be our answer, 8x over x plus 1. Okay, so now we're going to jump over and do number 7, part E. That is x cubed minus 6 over 3x cubed, and that is equal to 1/3 minus something. Okay, again, we have two terms in our numerator, so let's just break the fraction up there. We will have x cubed over 3x cubed minus 6 over 3x cubed. And if we look at this first term, we have x cubed over 3x cubed. X cubed is our common term. We can divide the top and the bottom by x cubed. On the top, we get 1. On the bottom, that makes a 1. So we end up with a fraction 1/3, which is what we have right here. So that means that on the other side, we must have the equivalent to 6 over 3x cubed. This is not simplified, though. We can divide the numerator and the denominator by 3, though. 6 divided by 3 is 2. 3 divided by 3 is 1. So we're going to write this as 2 over x cubed, and that is our answer. Okay, let's jump down to part G. If we look at part G, it's x squared plus x minus 7 over x minus 7, and that equals x squared plus x over x minus 7 minus something. Well, if you look, you can see we have the same denominator. So we know that whatever we're going to be subtracting, it's going to be over x minus 7. So we look at the x squared plus x, and that's right here. What's left? Minus 7. So here's the minus, and we write our 7. So 7 over x minus 7 is what goes in that last spot. Okay, now we're going to do one more part, part H. We have the same thing on top, x squared plus x minus 7. And this time on the bottom, and this time on the bottom we have x minus 7 again. But on the right side, what we have is x squared over x minus 7 plus something. We don't know what goes there. Well, if we look, we still have the same denominator, so we know we're going to have an x minus 7. And here's our x squared, so there's our x squared. So the rest of what belongs up there must be x minus 7. But is this in simplest terms? We have x minus 7 over x minus 7. We can divide the top and the bottom by x minus 7, which is 1 and 1. So actually, what's going to go in the blank, we have x squared over x minus 7 plus 1. So 1 is what actually goes in our blank. So that was number 7, which is just like number 13 that I assigned as homework. So you should stop the video at this point, work number 13, and then come back to the video to see how the next problem works. Okay, so now we're going to look at number 8. Number 8 says, change each of the following to the form described. More than one correct answer is possible. Now, it does not say on number 8 that you have to put everything in simplest terms. All the other parts for this lesson, you do have to put everything in simplest terms, but not this one. Okay, so it says write x plus y over 5 as the sum of two fractions. Okay, well, that's really easy because we have two terms in our numerator, so we could write this as x over 5 plus y over 5. That was an easy one. Now we're going to try writing 2x minus 1 over 6 as the difference of two fractions. The difference of two fractions just means we're subtracting. Again, we have two terms in the denominator, so we're just going to break it up that way. We have 2x over 6 minus 1 over 6. Now, for any other problem in this lesson, you would not be done at this point. You would have to simplify your fractions. It is okay to leave it in this form for this part only, but if you do want to go ahead and simplify, we can simplify this fraction. Divide the top and the bottom by 2. We get a 1 on top and a 3 on bottom. So this would be x over 3 minus 1/6. Okay, so now we're going to jump over to part D. I'm sorry, these were part A and B. We're going to jump down to part D. which says write 8x plus 7 over x as the sum of an integer and a fraction. Well, if we look at what's in our denominator, that's an x. Do we have any x term in the numerator? We do. So we should write that over the x to get an integer. And then we need to write the rest of our fraction, 7 over x. When we divide 8x over x, the x's cancel and we get 8 plus 7 over x. In this case, we do have to simplify because what the problem says is to write the answer as the sum of an integer and a fraction. 8x over x is not an integer. You have to divide the x's to get 8. This is an integer. 8 is an integer. 8x over x is not an integer. That's a fraction. So it says to write it as the sum of an integer and a fraction. So this one you do have to simplify. Okay, we're going to do 2 more parts from number 8. Let's look at part E. Part E says write x minus y plus z over x minus y as the sum of an integer and a fraction. Okay, so we need to look and see where we see an x minus y in our numerator. Well, we can see that right here. So that's where we ought to break it up. We will write x minus y over x minus y plus z over x minus y. And this first fraction, x minus y over x minus y, that's just 1 because we can divide the top and the bottom by x minus y and we get 1 plus z over x minus y. And that is our answer as the sum of an integer and a fraction. So the next one, part F, says to write 2x squared minus x minus 3 over x plus 3 as the difference of a fraction and an integer. So we need an integer, so we should look at our denominator and we see we have x plus 3. Well, in the numerator we do have an x and a 3, but they're negative and we need them to be positive. So I'm going to rewrite my numerator as 2x squared minus x plus 3 over x plus 3. Now this is still equivalent because notice if we do negative times x, we get our negative x. If we do negative times 3, we get our negative 3. So now we can break this up into 2 fractions. 2x squared over x plus 3 minus x plus 3 over x plus 3. Well, this second fraction simplifies to 1. So we have 2x squared over x plus 3 minus, sorry, not a plus, let me get rid of that, minus 1. And that is writing the answer as the difference of a fraction and an integer. So at this point, you should stop the video and work number 14. When you finish number 14, come back to the video to see how the last problem works. Okay, so now we're going to look at number 9. This is the last problem in the lesson. It says simplify each of the following. This means that you are not done until you have simplified your answer. I want you to notice that in this problem, everything is always in common denominators. So you're fortunate on number 9, you do not have to make a common denominator. Everything is already in common denominator. So you can just add or subtract as it says. So looking at part B, we have 4x over 4x plus 9 plus 9 over 4x plus 9. So they have a common denominator, so we can just write that down. And now we can add our numerators, 4x plus 9. Well, look at that. Our numerator is the same as our denominator. That means they can cancel. And we just have 1. So now let's look at part D, which is 2x cubed over 2x minus 5 minus 5x squared over 2x minus 5. We have a common denominator, which is 2x minus 5. And then in the numerator, we have 2x cubed minus 5x squared. We can pull out the x squared so that we have x squared times 2x minus 5 over 2x minus 5. The 2x minus 5 cancels, and we end up with just x squared. So that was number 9, which is just like number 15. You do have to simplify your answer, but for number 9, for the last problem you have for number 15, Everything is already in common denominators.